Hi everyone, welcome to today's session. My name is Elizabeth and I will be taking you on AWS Networking Workshop. So, the workshop that we're going to be working on today, I haven't tried my hands on it. I mean, that's really typical of the sessions that we have, trying them raw and learning from them, working with them together, and seeing where we find ourselves in the end year. So today we're going to be trying one of the AWS workshops. There are a lot of them. If you haven't checked them out yet, you should. It's a good way to get some hands-on experience and build your own portfolio of tasks that you have tried your hands at. And this is the one that I searched for today, this AWS networking workshop. It's really robust. I don't expect that we will be able to finish everything in 1 hour. I mean, here it says 8 hours. I don't expect it to actually take 8 hours, like the full 8 hours, but it definitely would be more than one session. So I expect that we'll be continuing that in the next live stream. And yes, so I already have it open here. It's originally part of the AWS Networking Immersion Day, and it has like 3 different workshops in one. I don't know if you can see it here. You have there are some foundational topics covered here. They say foundational. I don't really think they are only foundational. Like, there's the base networking, yes, but then it goes even further, like connecting to on-premise. And well, you say foundational in the sense of use case, but in terms of experience level, I wouldn't say this is foundational level, but um, there's enough content for learning, like no matter the experience you have. I'll try to explain and tell the whys behind some things if it's not very well clarified. But as usual, AWS workshops are very, very robust, so I expect that we even have more than enough information there. Okay, and then after the foundational topics, we see some advanced topics, and this, I would agree, definitely advanced. We're talking about gateway load balancer or transit gateway multicast. I know that most people would go through their entire career without having to deal with any of these two things. So yeah, so it's pretty advanced and maybe usually very specific. But back to where we are starting from, foundational. So here there is foundational. I don't think we'll be able to finish foundational today. I'll try to, but I want us to explore different workshops in the AWS environment, maybe also try our hands at implementing them with infrastructure as code. But some are really robust that I wouldn't say we should try implementing them with infrastructure as code on the sessions, because in a real life scenario, you would take a week or weeks, maybe multiple colleagues working on a project to actually deploy the infrastructure as code. Yeah. So realistically, console is usually faster. I may share some projects I work on, like maybe converting them to infrastructure as code, sharing them for you to look at, but it wouldn't be realistic to do like really complex or robust solutions together on sessions. It would take us weeks of 1 hour sessions to get it done. Okay, so where we're at, foundational, starting from here. And because we are going to be working in the workshop, they usually ask some things like either you are using this workshop in an AWS event or we are using it in your own account. And I want to say this because you may not be aware that doing the workshop in your account also means you are going to be paying for all the resources yourself and all. So if you are following along, be aware that there may be resources you will use that would cost something in your AWS account. So just be careful with that. And if, okay, yeah, they were here. Approximately $7 if it's in the US East 1 region. Also be aware that not all resources cost the same in every region. So if you're using a different region, you may get something different from $7. You can check the prices before you go along with it. But yes, this is the estimate. And okay, we can get started. Let's go. We'll be going with our AWS account. This notice is about the environment we are using. So if you are going to be using it in an event, there will already be like a pre-set up environment. But if we are not using it in an event like we are, we need to deploy the CloudFormation template. That's infrastructure as code, and it would provision some resources that I guess we need to have already before we now implement some things. So yes, and this warning also, especially if you are doing this workshop in an AWS environment that already has resources deployed. I don't know what you may have, but there is a quota for elastic IP addresses, so you may run into issues if you hit the elastic IP quota. Okay, now we can get started. There are 4 VPCs that are going to be created in the introductory labs. Fundamentals will create 1 VPC and 1 elastic IP address. Multi VPC would be 2 VPCs that will be created, and when we are doing the on-premises, it's going to create 1 VPC. Yeah. So we'll be working with this. Deploy prerequisites, and it's just explaining. So we're going to download this CloudFormation template here, and we're going to deploy it in our AWS account. These are the resources that are going to be deployed in this CloudFormation template. We're going to look at it when it's deployed. Yeah. Okay. Now I'm going to go log into the AWS account, console, dev. If you want to follow along and you don't have an AWS account created, you can do that now and join us. Yes, I'm going straight to my CloudFormation. Remember, it's a CloudFormation template we want to deploy. If you are going to be solving this kind of task normally in an ideal like day-to-day environment, you wouldn't need to be deploying this template at first, but it's because we are trying to create the situation. Like, okay, we want to start from a point where some things are already in the account. That's why we are deploying this template. Okay, so CloudFormation. So I'm going to upload an existing template. Actually, let me see if they wrote the instructions. I will just show you that before. Yeah, they wrote the instructions, yeah. But yeah, you go to create stack. You would choose the one to upload a template, and we're going to name our stack, and we'll submit. So basically, very simple. That's what we're doing here. So choose an existing template, upload a template file, and the template file, I need to put it here, download prerequisites. Yes, we can just click next, but I want to show you what it looks like in the infrastructure composer before we go. It should show you the resources that it wants to create. Yeah, so these are the things it wants to create. There's this flow logs role, there's EC2 role, and then there's an endpoint bucket that's created here. Okay, and let me see. No, yeah. So we're going to go to next and stack name, I'll just copy the stack name they use because I'm not going to think about that. Copy. There are no parameters defined in your template. So if there were parameters needed for a template, we would have to put it here. Like maybe they put some variables that you need to provide some name, you have to type it here. But our stack does not, our template does not have any parameters. So we're just going to create everything, leave it as usual. Roll back all stack resources. No, just leaving everything. I acknowledge that AWS CloudFormation creates and next. This is just to review everything that is happening, and then so our stack is being provisioned. Here we can see the events that are happening in our environment. Create in progress for, you see the flow logs row, the endpoint bucket we saw, and the EC2 row, exactly as we saw it. And we can see the resources being created here. Oh, most have been created. The EC2 instance profile is being created. Let's see. So it's still creating. But yeah, back to this while it's creating. Go to the next part. This is in an AWS event. We're not doing that. So already are the prerequisites. These are on AWS account, and we should be going to VPC fundamentals straight. This is where we'll be starting from. So AWS VPC, or rather Amazon VPC, I always say AWS VPC, but Amazon VPC is basically isolated networking environment in the cloud. And yeah, they say logically isolated section of the cloud where you can launch your AWS resources. And most of what we'll be doing today is just, plugging things up with our VPC, trying to move a lot of things around, like connecting between different VPCs in the environment and simulating as if we're connecting from the cloud to an on-premise data center environment, like all those things about connecting different parts together, hybrid networking and all. That's what we're going to be touching on generally. And I think this should be done. Oh, it's still in progress. Okay, let me see the events. Still in progress. I'll come back to it. So yeah. So in this lab, you will learn how to set up AWS Amazon VPC. If I say AWS VPC, please allow me to set up Amazon VPC with public and private subnets. If you've joined us in previous sessions, we would have done that at some point. But now we're going to be connecting to the internet, establishing private connections to AWS services. So if you know the VPC is an isolated environment, yes. And if you want to send requests out or anything, usually it goes to the public internet if you connect it to internet gateway. But there are ways that you can communicate between one AWS account and another AWS account without even going through the public internet. There are ways you can connect from your office data center, from your office network, from your house network directly to your cloud account without going through the public internet. So these are the things that we are going to be trying out. Please, I'm not sure if we're going to be trying out everything. I've not tried this this particular workshop, but I know that we're going to be doing some hybrid connections. I don't know if we're going to be doing like really dedicated like site to site VPN and all, but we're going to try some of these things. Okay, so the prerequisite section of this lab, let me see if we skipped it. No, we didn't. Yeah, we already did it. And then we can continue. So just a warning. Next would be creating the VPC. So I'm going to check if our cloud formation, yes, stack is complete. We have everything provisioned in our environment for us to start from where they are. That's what we were doing. Now we're going to go to VPC. I'm going to create a VPC. That's the instruction we have here. I think it's good for us to create. Yes, okay. I'm going to do this. I want to put this to the side so that we can easily reference both of them. Okay. Yeah, I think it'd be better that way. Yeah. Okay. I don't need this infrastructure composer anymore. Leave. Yes. So yes, we are here. Oh, I just saw a message. Thank you, local hosts. It's a pleasure. I'm glad that you're able to follow. And yes, back to what we were talking about. Networking. So yes, we are in our create VPC. We've clicked create VPC and we're creating only VPC. So normally if you create VPC and more, it's going to show you a lot of things that's going to be created. It's going to create the subnets, it's going to create the routables, all these connections already when you select VPC and more. If you want to create like very default normal kind of environment setup without any special things, you would want to click VPC and more because it provisions everything that you would need by default. But we're going VPC only because we're going to try and put all these things together by ourselves. Our name tag is going to be VPC A, yes, and our CIDR block is 10.0.0.0. So the CIDR block, as I always say, is a range of IP addresses that you are making available in your VPC, in your network. So this last part /16 is the mask of your CIDR block that tells the exact amount of IP addresses that you want to be allocated to this. And this part, it basically states the first IP address, like starting from this IP address, now provision the total number that is calculated with this mask. So starting from 10.0.0.0, we're going to have IP addresses that equates to /16, and we are not enabling IPv6. We are leaving default as the tenancy. And yeah, what else would we be doing? Asset proposal. So yeah, this is all that we're doing, creating the VPC toggle. Okay. This is very straightforward VPC creation. I wonder what we want to do with it. Okay, let's go and see our VPCs. Yeah, we have VPC A. Correct. And on the actions here, we said we should edit VPC settings from the drop down. We are going to be changing some things on our VPC. So we're going to select, let me see, actions. I'm going to edit this VPC settings. Okay, let's see. We want to enable DNS host names. So by default, DNS host names are not enabled in your VPC. It's usually IP addresses that your instances have in your VPC. But when you enable DNS host names, you are able to have like public, like DNS host names. Okay, I don't know which other way to, but like instead of just using the IP address, now you have like a domain name that would work with it too. I don't want to say domain name because you'll be thinking like, okay, that you have registered and all, but think of generated, like it's generated based on their IP addresses. And did we save? Was not yet saved. Yeah, going to be saving. That's all. We have our VPC. It's working. I mean, I believe it's working. We can't test it. But yeah, so subnets, we've talked about it. But subnets, I like to think of it like sub network in your VPC. It's just a smaller part of all the IP addresses that you have in your VPC, and then you just say, okay, this small part I want to use it for this thing, this other part I want to use it for that thing. That's how I'd like to look at subnets. You can be very basically isolating. Also, you can isolate things inside the subnet and not allow them to communicate with things in other subnet, even though they are still inside the same VPC. All right, so this is what we will be creating. Pretty straightforward. We have our VPC 10.0.0.0/16 is our insider block for the VPC, and then inside two availability zones we are going to be creating a public subnet, a private subnet each. And whenever you are working with your VPC subnets and all that, always be careful. Your insider block is, it's determines the IP addresses you have available. So as you are bringing out smaller insider blocks inside your VPC, it's going to be deducting from what is available. So it's like you're sharing it. So you need to make sure that you're sharing it properly, so that you have enough to go around for all the things you need it for. Okay, so we are using two availability zones. I am currently using EU Central 1 region, and in EU Central 1 region, normally we have 3 availability zones total: EU Central 1A, EU Central 1B, and EU Central 1C. You don't always have to use all 3 of them. We're going to be using only two availability zones, and the availability zone is like physical data center location in AWS global network, basically. So if something fails in availability zone A, if you have it set up in availability zone B, it's going to continue working even though the entire physical location of availability zone A is down. So it's for redundancy, for resilience. Okay, we want to duplicate things sometimes if the cost allows it. Now back to what we're going to be deploying. We're going to be putting this in our VPC, and we're going to be starting with the subnets. So you should have in your, this is meant to be my side navigation, but because I have this small window, it's going to be different. But in your side, you should have subnets here. That's where we're going to be creating subnets. The VPC is going to be our VPC-A. Make sure you are using the correct VPC. As you can see, I have a default VPC in my account. I'm not using that. Alright, so we're going to do that. And the subnet settings, this is what we're going to be using to configure it. So this is the first subnet in availability zone 1, and it's the public one. So I'm going to name it VPC-A public subnet AZ1. The availability zone is going to be EU Central 1A. I'm not using US East, so if you're seeing US East there, I'm using EU Central. I'm just pointing this out so you won't be confused when you see, oh, it doesn't match exactly what is here. If you are using a different region, also know that, okay, it's not going to be the same wherever you see the region. You should use the region that you are in. I mean, you won't even have any other option anyway. All right, so this is EU Central 1A, and the cider block, we can't use, this is the full cider block of our VPC. We can't use the full CIDR block as what we want for our subnet, because if we do that, we won't have CIDR blocks or ranges that we'll use for other subnets too. So make sure that you don't write the same thing you are seeing in your VPC. Put the smaller one. And if you are wondering how /24 is a smaller range than /16, it's calculated by subtracting from 32. Whatever is left is what is used to calculate 2 raised to power whatever is left. And here you can see we have 256 IPs in /24. If I type /16, you're going to see how many we have. 65,005. That's what is in /16. So yeah, we're going for /24. That's fine for us. I'm going to create subnets. That's all. So we're going to do this for all 4 subnets. Yeah, we're going to do this for all 4 subnets. For the next subnet, we'll start again. Select the VPC. We'll put the name. This one is the private subnet in the same availability zone. AZ1. VPC A. Private subnet AZ1. We're going to be picking the same availability zone. Remember, that was public, now this is private in the same availability zone. And the CIDR block is going to be, notice what changes. We don't have the same starting point for our IP addresses. Do you see that? It's this. The last one was 10.0.0.0/24. Now we're starting from 10.0.1.0/24. Because if we put the exact same 10.0.0.0/24, we won't be able to, those IP addresses are already allocated to the other subnet. So every of the blocks that we're using are going to be different. They're going to be starting from different points. Yeah. So we go, okay, click create subnet. Now we create a new one, and let me see the name of this one. Now we're moving to the next availability zone. That's availability zone EU Central 1B. Okay, let me type the name here. VPC A public subnet AZ2. And now I want to touch on one best practice in creating your resources in your AWS environment. It's not usually written, but if you see here, everything we've been creating, there's a pattern we have been following in naming them. We started, our VPC is called VPC A, and then if you see our subnets, they have the same pattern in their names. Nobody is forcing you to do that, but it's more professional. It gives a good overview on what you have in your environment. When I list my subnets, I can easily tell which VPC it belongs to. I can easily tell which availability zone it belongs to. I can easily tell. You decide the pattern you want to use in naming your things. When you're working in a team, usually sometimes it's already decided this is the pattern, this is the naming pattern for what we're going to be doing. So you need to be able to recognize a pattern, stick with it, and just create your resources in a way that it is easily navigatable. Is that a word? Yeah. But here you see VPC A. The public subnet there tells us which kind of subnet it is without even having to open it. And the AZ2 there tells us the same which AZ it is in. For me, there are projects that we use numbers. Like this is VPC A. For us, we can use VPC 001. VPC 002, VPC 003, and then when you are creating things inside it, you'll be like VPC 001, subnet 001, subnet 002, like that. So it's just, and then when you create resources inside the subnet, you'll see VPC 001, subnet 002, this, so it's just much better. Don't name things like in your hobby projects that I like using fun names in my hobby project, but using this opportunity where we see this, I want to tell you that this is a better way to name things whenever you're doing this in a professional setting, or yeah, just saying. Oh yeah, back to it. We're using EU Central 1B. Don't make the mistake of 1A. We're using 1B now. And this is our VPC CIDR block. We are going to be using a different CIDR block for our subnet as we did in the other one. Now you see that this time around we're using 2, starting from 2 for the third octet. So the first octet has 10, the second octet has 0, the third octet has 2, and the last octet has 0 in our CIDR IP address. This is just an IP address. This is the starting IP address. But for our mask, it's going to be 24 for our CIDR block, the same size as the other ones. And yeah, okay, we'll create this like that. We have one more subnet to create. I'm just going to move with it. The last subnet following the same naming pattern. VPC A private subnet AZ2. Availability zone preference is also EU Central 1B. And as you can see, for our CIDR block, it's going to have 3 in the third octet because that is where the IP address continues from in this subnet. So it's really just sharing the IP address. It's just like that. And we are done with creating subnets. So I'm going to remove this filter and we can see all the subnets we created. 4 of them. Yeah. Okay. And you can see originally the IP addresses there were 256 and now they are 251. I have mentioned in one of my recordings that there are 5 IP addresses that are always reserved in any environment. 5 IP addresses. So whenever you are provisioning IP addresses in your AWS environment, make sure you include those 5 in your calculation. And some extras. Yes, okay, we're done with our subnets. And we can see all of them. We'll move on. So the access control list. The access control list, NACL, I don't know if there's a nicer way to call them, but NACLs are usually attached to your subnets and they provide a layer of security. You know, I said that you can restrict what happens in one subnet compared to what happens in another subnet, even though they are in the same VPC. That's what you do with these ones. And we're going to be implementing that. Yes. So select any of the subnets. We're going to follow the instructions here. We're going to select any of the subnets and we're told to come down here. You see these tabs? You can scroll through them. This is the network. Let me refresh this page. Maybe we'll select this one I was selecting. Yeah, this is the network access control list. And here these are the rules that we have here currently. So depending on the rule number, it's going to execute the instructions that match it. Maybe allow this or deny that. And the first one it meets in the order of priority is what it's going to execute. So if there are still more matches to your traffic, on that you didn't prioritize the rule properly, it's not going to be properly resolved. So default ones allow all traffics and deny all traffics. Yeah. Now what we want to do is we're going to create a new network access control list for workload subnets in our VPC. So we'll go back here. We're going to click network access control list. In this place where there's security, can you see there? We're going to click network access control list and I'm going to be creating a new network access control list. Okay. network access control list, enter name. Yeah. So this is going to be named VPC A workload subnets NACL, and the VPC of course is VPC A. That was quite obvious. I'm going to create this. Oh, yeah, I didn't check if they wanted us to do anything else. Yeah, they just wanted us to create it. So the result is a new network access control list we have here. Currently, this is what is attached to the other ones. All the 4 subnets are attached to this one. But now by creating a new network access control list. Yeah. This one is the default one. This previous one is the default one in our VPC. So every subnet you create is automatically going to be assigned that network access control list if you don't add another one to them. And this other one here is also the default in the other VPC that I showed you. So yeah, basically it's just default. Everything is going to be attached if you don't have the specified one. So we are going to go to network, the subnet associations on our network access control list, and there is no subnet association right now. We're going to edit the subnet associations. We want to add this. I'm not sure if it's everything we want to add to it. I don't think we would want to add the same ones. Okay, I don't know why they want to add all the 4 together, but yeah. Normally I would separate okay, I'll put in the 4 of them. Network access control list. I mean, when you put the rules, you can specify what goes to what anyway, so no problem. We've saved changes, and we see the 4 of them are associated with this network access control list now. And if you pay attention, you would also see that they were removed from here. Yeah. They were removed from here. So you can't have all the different network access control list on everything. We need to allow on our network access control list, this one that we're looking at here. We have 4 subnets associated, yes. Our outbound rules denies everything. Our inbound rules deny everything. So when you create a network access control list, everything is denied by default. You probably wonder why then the default network access control list allows everything. Yeah, because that's the default things, and that's why we always say try not to use default things every time, because they're just made to work. So this allows all traffic. This is the default in this VPC. You don't want to use that for your secure like workloads. So here I am with this one. Okay, in the inbound rules tab, we are going to edit our inbound rules. We have only deny rule on our network access control list. When we create it, everything is denied. Now by editing this, we're going to add a new rule. Let me see what rule we want to add. The rule number is going to be 100. So I have something to say. There's nothing that says the rule number has to be 100, but I don't know where that unspoken rule came from. Maybe I need to go and do more research. But I realized that mostly, like, we usually do 100, 200, 300. And then, as things get more complex in your environment, you may need to insert more rules, like, in between. Like, okay, this is the order of my rule. Now I want to add one in the second position or something. Now you go and put 150. Then you want to add one before that, you could just put 120, 130, or put in 101, 102, 100. Like, I can literally type one here and it will work. I don't know why we usually go with 100. 100, 200. About, yeah. Rule number 100. Type allowing all traffic. The source is from anywhere. Anytime you see 0.0.0.0 is from anywhere. And leaving everything else, we're going to save changes. Yeah. If they were going to do this, why didn't we just stick with the default access control list? But yeah, it's the exercise that matters, yeah. So we have our inbound rule, we have the allow that we added is now added to it. So yeah, I guess now you know how to edit your network access control list to add new rules and maybe remove existing inbound rules. Also for outbound, we're going to do something too. So our outbound rules, we only have also only deny here. We need to edit it. And I'm guessing we're going to allow everything again. Yeah. Brethren, please do not do this in production. I'm just saying. But yeah, it's the exercise that counts. You don't really want to be just allowing, yeah. So port range, no, we're allowing all traffic from everywhere. Allow. Okay, save changes. Wait, did I write 100? I think I wrote, yeah, I wrote 100. Okay. And we have added that rule. We have it here, as you can see, is the first one in our outbound rules. I wish I had much more screen space to show you everything very well. It feels like this is too crowded. There's so much AWS things I want to remove from my page. Allowing all traffic in and out of subnets. Okay, they wrote it in the end, just what I was telling you now. Don't do it in production. It's good that they put the notes there. It's just for exercise. Allowing all traffic in and out of your subnet is not a good security posture. You don't want to be doing this. You can use this network access control list to set your rules, like your allow and deny rules, and also security groups to set your allow rules, but try not to just open everything up. Yeah. Next, root tables. So, okay, just checking the time. Okay. So root tables. We have everything around our subnets almost set up. Yeah. So the root tables essentially allows your subnet to know what to do with what. It's different from the network access control list, because here in the network access control list, you see the rules are saying allow or deny, allow or deny. It's basically like gatekeeping. But the root table actually gives instructions on what to do with traffic from a particular place. Like, okay, if the traffic is coming from here, direct it to this location. If the traffic is coming from this, or if it's going here, direct to this location. Like, that's what the root table does. So it's not gatekeeping in that sense. If what you are trying to find is not on the root table, it's going to what they call this thing, to route to default, like 0.0, like there's this, you know, the one I said anywhere, that IP address 0.0.0.0/0 is going to match that and go with whatever rule is there for 0.0. So we have to attach the root table. I expect there should be a root table, maybe a default one, I guess. Let me see. Oh no, this is on the network access control list. Let's go back to our subnets. Yeah, so we have this first subnet A selected, And the root table here is this one. Let's have a look at it before we continue with whatever they have for us. So this is the root table, and our subnets are using it. It's because they are not yet associated with any root tables, and this is the main root table in our VPC. So most things have default here. The main root table in the VPC is what your subnets would use if you don't associate them with a specific root table. This is all you're going to be using to root. And for our root table, the roots in the root table, that's what you're going to see in every of the subnets. If you select them in the root table, you see just our IP address CIDR range, IP address range in our VPC, and it's going to be targeting local. Local basically means check internally, check within this VPC and find where you're going to. That's what it means. So yeah, back to what we were. So we need to add routes. We need to add the routes to our table. We need to add the routes to our table. Okay. Let me see. I'm trying to look at this. These IP addresses, I'm looking at them because they don't look like what we used before, but I guess it's just, we'll see. Let's go and see what it is. So I'm going to create a root table, our own, not the default main one in our. So I'm going to go to root tables here, and I'm going to click create root table. The VPC is VPCA. Everything we are doing right now is VPCA, and I want to correct the name. Yeah, the name is VPCA. At this point, I think I should be able to be guessing what the names are because they are consistent in the pattern. So VPCA public route table, and the VPC is of course VPCA. We are going to just create a table, there's nothing specific, and then we can edit the rows after that. Let me create it. Okay, there's only just the local route here. The same route that is in the main table. Like this is just our IP address range for our VPC, and it's saying local. Okay. This allows for routing within the VPC environment, but of course anything that doesn't match this is not going to find its way, except if we add a route that says 0.0.0.0/0 to accept every kind of IP address that doesn't match a more specific one like this one. Now we are going to go to subnet associations. We're going to add it to the subnets. Okay, let's go. Subnet associations, edit subnet associations. We are adding only the public subnets. Remember, this is a public route table we created, so we're going to add our public subnets. I'm going to save association. So now we have explicitly associated these two subnets with the root. Let's look at these subnets to see what they look like now. This one in the root table, you can see that the root table that is there with us now is the one we associated it with. And you're also able to edit the root table association from this side. You know, you could edit it on the root table, you could edit it on the subnet, but yes, we are able to edit it from here. And if I change it, of course it's going to change what is using. So here the public route table, I'm not making it, the public route table is associated with the public subnet and receives the association. Okay, now we're going to create a route table for the private subnet too and do exactly the same thing again. Now we are adding the create route table, VPC a private route table, and the VPC is VPCA. We're going to create this route table, and then we're going to edit the subnet associations. Exactly what we did for the public subnets. So now the private ones. Save the association. Yeah. Okay. So I think we're good with everything for now. We save the associations. In our subnet associations, we should see the private ones. So we have the private route table associated with the private subnets, and we have the public route table associated with the public subnets. As you can see, even though they are in different availability zones, we're able to still use them together within the same VPC. We're able to, put them on the same network access control list, put them on the same route tables and all, because they are all within the same VPC. We won't be able to attach this to, if there were different VPCs, there's a lot more we'll have to do to make them work together, than just attaching the routes. And here in the resulting, we're already past here. Okay, next, yes, we have our route tables here, everything in our route tables. Yes, we have the fourth one, which is from the other VPC, remember. Now we want to set up internet connectivity. We're making a lot of progress. Now we have our route tables, but remember, in our route tables we have only the local route. We have only the local routes there. So for them to be able to possibly fetch things from the internet or update or load things, they need to have a route that will tell them what to do when the IP address is not in our local environment. Like this IP address is somewhere like Google or something, it needs to find its way there. So we're going to add an internet gateway and a NAT gateway. We can add internet gateway to the public subnets, like they can use internet gateway, but our private subnet needs to be really private. We don't want it to have direct connection with the internet gateway. That's when we now use the NAT gateway. So what the NAT gateway does is it allows your private network to communicate with the internet indirectly. So the NAT gateway is deployed inside a public subnet. Okay. It is deployed inside a public subnet, and then your private subnet is able to communicate with the public subnet or send traffic to the public subnet, and it's the public subnet then handles the connections with the internet, because our private subnet is those extra layers make it such that our private subnet is not having any direct contact with the internet. So any incoming traffic or something goes through the public, because then why would you be calling it private if it has direct internet access and all? But we'll be seeing all of that here. Okay, so internet gateway establishes an outside connectivity, and to deploy in the VPC, yes. A NAT gateway provides outbound connectivity for workloads running in private subnets. So this is what it looks like. This is what it looks like. This, I wanted to show you just now. Where is it? This here at the edge That's a symbol for internet gateway. You can see it's at the edge of our VPC. It's connecting our VPC with the outside connectivity. Whereas this one here, inside here, is the NAT gateway. This is the symbol for the NAT gateway. Here, it's connecting, our private subnets are able to use the NAT gateway, but they are not connecting directly to the internet gateway. Like, you wouldn't see any of the routes in the private route table pointing to the internet gateway, but you may see them pointing to the NAT gateway. You understand how that works now? So the private subnet is communicating within the VPC, then the public subnet can communicate outside the VPC, basically. And there are other ways that this used to be set up in the past. Now we use NAT gateway, yes, but there's something that we used to call, okay, let me not go too into that, but normally, they will deploy like this instance, like server EC2 instance inside the public subnet, and then you will now connect from your private subnet to that EC2 instance to connect with the internet. But that instance is what is connected to the internet, not the private subnet instance. You get? So it's just some form of security measure. It's still done here, but yeah. Okay, so we're going to deploy the internet gateway. I think this is the last part we're going to be doing, this internet connectivity part. So we're going to deploy the internet gateway. Still in our navigation on the side, we should have internet gateway here. Internet gateways. When you create internet gateway, there's an internet gateway here already attached to that default VPC, but we're going to do it afresh. So it's going to be VPC IGW. Anywhere you see IGW, it means internet gateway. Anywhere you see NGW, it's NAT gateway. If you see TGW, it's transit gateway. If you see like all these abbreviations in AWS, you will pick it up definitely over time, because I mean, why would I be typing internet gateway? But yeah, VPC IGW, create internet gateway. Yeah, we have it. And that's all. We have this created, it belongs to us. The state currently is detached. We need to attach it to the VPC that we want it to be on. So the VPC is VPC A. Did you notice something? Did you notice that when I selected this drop down, I only had this option of this VPC. The other VPC is not showing here. You can only have one internet gateway for a VPC. I mean, how many paths do you want to pass to the internet? You can only have one internet gateway. If I try to, okay, no, well, you can see I've attached it to this VPC. But if I try to attach an internet gateway to a VPC, again, I wouldn't see this one there. So it's attached. And now we should have this, but we need to point to it. So we'll go to our VPC route tables, the route tables we created, particularly the public, wait, it should have, yeah, okay, public private, the public route table. The public route table should point to the internet gateway. Okay, I want to add a route. Normally I would say anywhere. This is zero. This is what I was saying. Anywhere 0.0. I want you to point to our internet gateway. This is our internet gateway. This is what we want to do. Yeah. And as you can see, we're going to edit the route, and basically the same thing. We're going to put 0.0.0 and point to internet gateway. So anytime you see that your VPC is not having connectivity to the internet, check to make sure that your internet gateway is set up and it is attached to your VPC. Then check that the subnet that your resources are in has the internet gateway route. It has this route in the route table, and it's able to match 0.0. This means all IP addresses. So if it checks the routes in your route table, it doesn't see one that really matches accurately. It's just going to default to anywhere and put it to the internet. Okay, so these are ways you can debug your connectivity. And then we're going to just save that, and we should have that. The next thing would be our NAT gateway. As you can see now, it's pointing to our internet gateway. This is the public route table. Please be careful. This is the public route table. Make sure you didn't go and put your internet gateway in your private route table. Remember, I said you don't want your private to have direct connection to the internet. So now we're going to be going to NAT gateways. I'm going to create a NAT gateway also. Let's see which one. The name is VPC NAT gateway, and we're choosing the public subnets. You can pick any public subnet in VPC, but we'll go with the first one. So we are trying to create connectivity for our private subnets. I already explained this, but just to reiterate, the NAT gateway is going to be deployed in a public subnet, and our route table that is on our private subnets would now be able to point to them. Okay, so the subnets connectivity type, we are going to be using, yes, let's see, leaving it as public, allocate elastic IP, quick, yeah. So I'm not going to do this as the existing ones that we already created. So I'm going to allocate, you can see it created a new one. So allocate elastic IP, and then we create the NAT gateway. But just to point out that elastic IP addresses are available in your VPC. Elastic IP addresses are useful to you for the resources you're deploying. Even when you deploy a server or something, you can attach an elastic IP address to your server such that every time they restart, or you shut down, you create, and the IP address changes, it's not going to change the elastic IP address. It stays the same. This elastic IP address, you can attach and detach it from, it's just an IP address, basically a reusable IP address that when you use it, it stays the same, and then you can always remove it and use it for something. Yes, so we're creating this NAT gateway. Now we have our internet gateway already configured properly for the public subnet. We just need to set up our NAT gateway, and then we'll call it a night. So we have already created the NAT gateway, and we need to configure our routes. Okay. Here they said it's best practice to create a NAT gateway in every availability zone. Yes, but always remember also that it's costly. You want to have different ones to allow for redundancy. Like, okay, even if one goes down, we have one connectivity that is working that we can continue to use. But whenever you do things, also remember that multiple NAT gateways are costing money. Yeah, just know NAT gateways are expensive. Update route table for, so we need to go back to our route tables and update that. Close this so that we have so we're going to the route tables, and we're going to click on our private route table. That's what we're going to be editing. So we'll go to the routes, we're going to edit routes, we're going to add a new one. Our own anywhere in this private is now going to be going to a NAT gateway instead of internet gateway. That's the difference. So we can save changes on this, so you can see it now. On the public route table, we put the anywhere destination to point to internet gateway. It has changed here, and now we have the routes configured on our route tables. I mean, this works fine. Yes. In a traditional environment that you set up, this may not be all that you would have to do. I'm saying this because when we set up the network access control list, we allowed all traffic into, yeah, where's it? Yeah, we allowed all traffic into that subnet, into the subnets. But in a situation where you have different network access control lists that are denying traffic, allowing traffic, you may also need to check your network access control list for the public subnet to make sure that, okay, um, it is allowing the traffic from the private subnet. That NAT gateway that we are pointing to is deployed inside the public subnet, is inside it. So if you have a rule in your network access control list that is blocking your private subnet from communicating, it won't work with the NAT gateway. So after what we have set up here, if you have such kind of rules, you need to come here and make sure you allow traffic from your um, private subnets. I'm just saying this in case you ever encounter a situation that, okay, you set it up properly and it's still not working. Check all your rules to make sure it's allowing. And yes, this is where we'll be starting. This is where we'll be stopping for tonight. Thank you so much for joining. I hope that you have learned a lot and maybe you have some of your questions answered, or some things you want to try out yourself. Now, okay, they said we have now gone through the bread and butter of AWS networking. Okay, they say so. But yes, next week we'll be continuing with VPC endpoints. So this is where you can set up endpoints that you can privately communicate with AWS services within your VPC without having to go through the public internet to communicate with those AWS services. For instance, if I have a server that is fetching something from S3, AWS S3 is a storage service. Normally, that would go through the internet to fetch something from S3. But if I don't want my private subnet to have to communicate through NAT gateway and all of that, and I want to fetch something from S3, I can set up an S3 endpoint and I would be able to communicate securely without having to open up my traffic to allow internet connections. It will be able to connect through the AWS environment securely. And I mean, it's more secure apart from the fact of the additional rules. It's also more secure because it's not going through the public. So yes, we'll be continuing from here next week. I look forward to seeing you. Bye bye.